All right, we're going to learn some new concept. It's called a complex numbers. What does that mean? Other than the complex numbers, are there simple numbers? Okay, so what does complex number mean? Now, we do a quick review. What is the square root of 25? 5, right? What is the square root of 121? You can use calculator, or you might remember this. It's 11. Okay. So what about square root of 1? It's 1. What about square root of 0? It's 0. Because 5 squared is 25, 11 squared is 121, 1 squared is 1, and a 0 squared is 0. Okay, so I'm sorry that I have to make this really bright because it's dark. All right. Now, next. What about the square root of -1? Do we know this? We don't, because we cannot find any real number. You square that, you get a -1. So it's a new concept. That's what we're going to learn today. And we call this I, little I. And this I stands for imaginary unit. So that's imaginary, right? So that's little I. What does that mean is I square is -1. This I, you probably think, well, I don't see that. I cannot understand. Yeah, don't worry. That's not a real number. Okay, it's not a real number because in the real number world, we cannot find any number. You square that to get a -1. But in the imaginary world, it's possible. All right. So what about a square root of -25? You're going to think that -25 is -1 times 25, and that 25 goes out. So you get a 5 times square root of -1, right? So that answer is a 5i. All right, now you probably see this negative goes to I. You take the square root, and this 25 goes to 5. So it's not too bad, isn't it? So this is a new number system, imaginary number. All right, now, what about this I squared is -1. What about I cube, which is I times I squared? And every time you say I squared, that's a -1. So this is -1 multiplied by I is -I. Okay, and I to the 4th, which is I squared times I squared, and I squared is a -1 times -1 is 1. Okay, so what about I to the 5th, which is I times I to the 4th? And we know I to the 4th is 1 from here, so that is just I. Okay, so what about I to the 6th? That would be I squared times I to the 4th, and I squared is a -1. I to the 4th is 1, so that's -1. Wait, it goes back to here, right? So what about I to the 7th? So that would be I times I to I to the 6th. And we know I to the 6th, the power is a -1. So here is a -I. Did you notice that it repeats? -1, -I, 1, I, -1, -I. Of course, the next one will be 1 and the I. So that's help you to figure out what is I to any positive integer power. Okay. So this is the important thing about the I, the imaginary unit. Now, when we talk about a complex number, let's say 5 minus 3i. All right, this is the real number, right? Or we call this as a real part. Okay, so this is a real part. And this is the imaginary part. Imaginary part, and that -3 is a real number. Okay, so 5 minus a 3i, that's a 5 as a real number minus a 3 imaginary unit. So that's what it says. All right, this is called a complex number. If you have a two complex number, a plus bi equals c plus di, which means the real part are same and the imaginary part are the same, or the real number before the imaginary unit is also the same. So these two are equivalent to each other. Okay, so if you have a plus bi equals c plus di, which means the real equals real, imaginary equals imaginary. Okay, so that's some property we know. And the next we're going to learn how to add or subtract two complex numbers. So if you have a plus bi, this is a complex number. If you plus, okay, c plus di, then you just add the real part, which is a plus c, and then you add the imaginary part, but of course you're going to add the real number of that imaginary part. So real plus real, imaginary plus imaginary. And if it's a minus bi, sorry, a plus bi minus another one, c plus di, then it's going to be a minus c plus b minus di. It's not bad, right? It's not difficult at all. So let me just give you quick example so we can practice a little bit. Okay, the first one is a 5 minus 11i plus, see, that's a summation of two complex numbers, so 7 plus 4i. How do you do this? This is the real part, imaginary part, real part, imaginary part. Here's a plus, so real plus real. So I get a 5 plus a 7. Okay, and then here's going to be negative 11 plus a 4i, right? So real, real, imaginary, imaginary. So the answer is 12. And here, negative 11 plus a 4, which is negative 7, so it's going to be 12 minus a 7i. Not bad. One more. Negative 5 plus I minus negative 11 minus 6i. Okay, the real works with the real, so that's negative 5 minus negative 11. That's a real, 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 and here's minus. That goes here. And then the next one, when there's nothing before I, which is 1, okay, 1i, you don't need to write that 1, so you just write I. So here, therefore, here's 1, and then minus negative 6i. It's like combine the like terms, right? So negative 5 minus negative 11, which is a 6. Okay, 1 minus negative 6 means plus positive 6, so that's a 7i. That's your answer. All right, now we learn how to add or subtract complex numbers. Of course, the next one is going to be multiplication. We have two complex numbers, we're going to multiply them. Okay, how should we do that? Quick review of FOIL method. A plus b times c plus d. Okay, FOIL, first times the first, which is a times c. O means outer, out times out, so that'll be AD. I, that's a BC. Last, BD. Right? That's the FOIL method. What about if you have an I? Say if you have A plus BI times C plus DI. Again, we use the same procedure. That will be first times the first, A times C, AC. Outer, A times DI, which is ADI. Don't forget this I. Inner, which is BCI, right? These are three letters. And the last one is a BD and I square. All right, you know what is I square. You have to remember this. You have to know this. Okay. Okay. I square is always negative 1. So here is negative 1. That means here you can change that into AC minus BD. That's a real part. And this is your imaginary part, and you take I out. So you're going to have AD plus BC I. So this is the standard form. That's a real part, imaginary part. Always do that in this order and write it like this. Okay? So I'm going to give you one more example, the real example. Let me do this. 7 minus 3i times negative 2 minus 5i. FOIL method. First times the first. 7 times negative 2, I get a negative 14. Okay. Again, you don't need to remember A, B, C, D, all those things. As long as you remember FOIL method, it should be good enough. So first times the first, outer times outer times outer. So that is 7 times negative 5i, which is negative 35i. Okay. Inner, negative 3i times negative 2. Negative, negative becomes a positive, and the number is 6i. And the last, negative 3i, negative 5i, I got a positive 15i squared. And again, this I square is negative 1, right? That's the most important thing we learned in this section. So that would be negative 14. Here is going to be minus 15. That's a real number part. Okay, and the imaginary number part is negative 35 plus 6, that many I. All right, now the last step, negative 14, negative 15, I get a negative 29. And here, negative 35 plus 6 is also negative 29. I. That's my answer. Okay, so once you have two complex numbers multiplied by each other, you can just use a FOIL method, and be careful, the last step, that I square, the last product, I square is a negative 1. So that's why you don't have the I square in your answer here. All right, now another one. It looks fairly easy. 4i times 3 minus 5i. And this one is actually it's a 0 plus a 4i, but we don't have to write a 0. We don't worry about that. We just use the distributive property, distribute this into the parentheses. So 4i times 3, that is 12i. 4i times negative 5i, I got a negative 20i squared. Then this I squared is a negative 1. I don't know how many times I need to repeat that, but I'm going to repeat a lot. So this I squared is negative 1 multiplied by negative 20. I get a 20 positive, and then plus 12i. That's a very, very good answer I have. Okay, so we learned how to add, how to subtract, how to multiply. Of course, the next thing will be division, right? Okay, when we do division, we're going to use like a plus bi divided by c plus di. How should we do that? I'm going to introduce you a new concept. It's called conjugate. Okay, what is a complex conjugate? And I think a long time ago, you remember like a 2 plus 3. Okay, 2 plus square root of 3. This one, 2 plus square root of 3. If you have something like a 2 plus square root of 3, if I ask you to simplify this, remember I don't want to have I in the denominator. I don't want to have square root in the denominator. How do you get rid of this square root in the denominator? You're going to multiply by its conjugate, which is 2 minus root 3. 2 minus root 3. That's how you do that. I don't know if you remember that. You multiply by something for both numerator and denominator. You're not changing the value. And the good thing, you multiply by the conjugate, there's a formula, is a plus b times a minus b, which is a squared minus b squared. Okay, so this is the square difference formula. However, if you don't remember, you can just use a FOIL method. This is a squared, and this is negative ab, and here's a positive ab. It canceled out. Two middle terms canceled out. So the last term is a negative b squared. Okay, so the good thing about that, once we do 2 plus root 3 times 2 minus root 3, the answer will be 2 squared minus root 3 squared. So we don't have a square root anymore, and the top is 2 times that, so it's 2 times 2 minus root 3. Okay, so the numerator becomes a 4 minus 2 root 3, and the denominator 4, right? 2 squared is 4, and the square root of 3, you square it go back to 3. So the denominator is 4 minus 3, which is 1. So your answer is just 4 minus 2 root 3. this is when I ask you to rationalize a expression, which means I don't want to have the square root in the denominator. Okay, so that's the first time probably you have heard about this conjugate. But for a complex number, like a plus bi, its conjugate will be a minus bi. Why? Because a plus bi, if you multiply by a minus bi, it's going to be a squared minus bi squared, right? Same formula. So that is a squared minus b squared I squared. And do you remember this I squared is -1? So what it will do is change the sign here. So that will be a squared plus b squared. See, no I, okay? You only have the real number. So that's why this a minus b is called the complex conjugate of a plus bi. Why we need to do this? Okay, so it's very similar to this one. If you want to divide it by a complex number, you're going to multiply by its conjugate from the both numerator and denominator. Okay, what does that mean? Okay, so let me work on this example. I ask you to simplify this. 7 plus 4i divided by 2 minus 5i. Remember, I don't want I in the denominator. So what you're going to do is this. You multiply by the complex conjugate. Here, so far I just copied this. I multiply by the conjugate, complex conjugate of the denominator. So here will be 2 plus 5i, and here is 2 plus 5i. So literally, you're multiplying by 1, you're not changing the value, so that's why you can have equal here. So forget about that. Okay, here's minus. All right, now we're going to continue. And the numerator, I'm going to use the FOIL method because that's the product of two complex numbers. So 7 times 2, which is a 14, and the outer 7 times 5i, I get a plus a 35i, and the inner, which is 8i. See that? 4i times 2. And the last one is a plus 20i squared. Okay, I'm going to do that later. And the denominator, again, you can either use the formula a plus b times a minus b, which is a squared minus b squared, or you can use the FOIL method. So that will be 4, okay, because 2 times 2 is 4. And then this times 5i will be positive 10i, and the inside will be negative 10i. So that plus 10i minus 10i get canceled out. If you like, you can write it. Okay, so plus 10i minus 10i. Of course, it's going to cancel out later. And then the last term is negative 25i squared. All right, now we're going to replace I squared by -1 and then combine like terms. So the numerator here will be negative 20 because I squared is -1. 14 minus 20, I get a negative 6. 35i plus 8i, I get a 43i. Okay, so that's the top. And denominator, I squared is -1 times negative 25 is a positive 25. So 4 plus 25 is 29. Okay, if I write that into a good form, it's going to be like this. This is the real number part, and this is the complex. This is the imaginary number part. That is your answer. Okay, so can you remember this? Okay, so it's not bad, huh? All right, now after this, we're going to do a little bit more. If you remember that a while ago, I said a square root of negative 25. I just take 5 out, and then I get a 5i. Do you remember this? Yeah. All right, now let's work on 3 questions. The first one, square root of negative 18 minus the square root of negative 8. Can you simplify this? Do you know what is the square root of 18? Square root of 18, we have to see whether there is any factor of 18 that is a complete square. So 18 is 9 by 2, right? So that's 9 times 2. And this 9, you take the square root of that is a 3. And it will be like this, okay? And since here is a negative, So I will just have an I after that. So I get a 3 square root of 2I. Okay, and then the negative 8. Let's forget about the negative. We do square root of 8. Square root of 8 is 4 by 2, and that 4, you can take it out. Take the square root of 4, you get a 2 square root of 2, right? So square root of a negative 8, I will get 2 root 2I. This negative comes from here, okay? Now I got something about I, and I combine the like terms. So 3 root 2 minus 2 root 2, which is just the square root of 2I. See? You simplify that, and you get this. Okay? So let's try one more. Move my paper. Okay. One more. Can you do this? Negative 2 minus root negative 3 square. So I would ask you to do is to rewrite that as negative 2 minus root 3I. Can you do that? See, you keep the root 3, but instead of having a negative inside, you just replace that with I and a square. Or you can just multiply by itself, because that is what a square means. And then the rest will be just the FOIL method. So you get a negative 2 times negative 2, you get a positive 4. Okay, negative 2 times negative root 3I will be positive 2 root 3I. Okay, and this negative root 3I times negative 2 is plus 2 root 3I. You don't want to miss anything. And then the last one, negative root 3, that becomes a positive 3, and then I square. Okay, so what is I square? Negative 1. So here becomes negative 3. If you combine this, a 4 and a negative 3, you get a 1. And here, 2 root 3I plus 2 root 3I, you get a 4 root 3I. There you go. Okay, so that is this one. And the last example is this. Okay, write the result. Okay, so I'm going to get negative 14 plus negative square root of that over 2. Can you do this? Yeah. Okay. So I get a negative 14 for root 12. That is 4 times 3, and the 4 is a complete square, goes out, and that's this, right? So here will be negative 2 root 3I over 2. Okay, and then the real number part will be just negative 14 over 2, so that's negative 7. And the other side, the imaginary part, this 2 and this 2 canceled out, so I get a negative root 3I. When you work on this type of questions, you might want to be super careful and to make sure that you're not missing anything. Okay, so that's everything for this complex numbers. It looks complex. What do you think?